Today we're going to be reviewing the Lion Energy Safari LT. And this is a solar generator or a battery that has an inverter, a solar charge controller, and everything else you need. All you have to do is connect some solar panels and some appliances and you are done. And this is literally the first time in months that I'm actually excited to do a product review because everything that I've been testing lately has been pretty pathetic. But this unit, for its battery size, has the fastest charge rate on the market. It can charge at 140 watts. So we're gonna test it today and see how well it works. And I'm actually excited. I can't wait to see what happens. Wow, this thing is bigger than I thought. Look at this thing. So in the pictures, I thought it was smaller for some reason. I knew that the battery size was pretty big, but look how big this thing is, you guys. So let's talk about the stats. First off, it has a 450 watt hour battery and it has a 500 watt inverter. And so on the front, we have an input and an output. So if you want to charge up this battery, you will plug in the AC adapter wall charger right here. And if you want to charge it with a solar panel or your car cigarette lighter adapter, you charge it right here. And this can handle 140 watts and it's current limited, which is really nice. Which means that you can over panel and connect 200 watts of solar panel power right here without damaging it. And then on this side of the unit, we have the output. So we have 12 volt, 5 amp DC power plug receptacle. We have USB ports with a quick charge, and it's a USB-C, which is really nice. And then we have a 12 volt, 10 amp cigarette lighter adapter on this side. And all of these plugs have this rubber cover, and I guess it's for durability, but I'm not sure what the waterproof rating is. Then if we want to turn it on, we press the power button right here, and it will tell you the input and the output. If you want to turn the output on, you turn it on like this, and then the light will turn on, and then you know that you have power at the DC side. If you want to turn on the AC side, you need to press this button over here. Then a light will turn on, the cooling fans will start up, and you will be able to see how many watts it is using. And when the inverter is on, you can hear a slight hum in a cooling fan. And let's just turn it off. We're going to test it in a second. And then you can also turn on the backlight by pressing the power button. And the moment you connect a power source to the input, this side will show how much power is going into the battery. They gave me two chargers. This is a very slow wall charger. And then they gave me this huge beefy Anderson power pole 150 watt charger. And then we also have a cigarette lighter to Anderson power pole. And the fastest charge rate that I can achieve is 139 watts. Because this is current limited to 140 watts. So even though this can push more, the unit can only handle 140 watt input. So there you go. Now let's compare the quick charger to the slower and smaller wall charger. And the fastest rate I can get is 49 watts. So that means it will take 3 times as long to charge with this small one compared to the larger one. For the second half of this video, we're gonna connect solar panels, test the inverter, but I have to mention the biggest downside that I have seen by reading the manual. When I do the testing, we might find other downsides, but the biggest downside that you guys need to know is that the 12 volt receptacle is not regulated. The company actually told me this before I did the review because they know how much I love having a regulated output. But when they told me how fast it charges, I was like, all right, I'll just test it anyways because it sounds great. I mean, this is like the fastest one for charging on the market, but the 12 volt output is not regulated. So right now we're at 50% state of charge. We only have 10.9 volts available. So let's say you want to power a 12 volt fridge. There is no way, because most of the cutoff voltages for those DC fridges is like at around 11 volts, 11.5 volts. Some of them are programmable up to 12.3. So in my mind, if I were to buy this, I would not be buying it for the 12 volt as a source. I would be using it for USB or an AC output. And right now we do not have enough sunshine to actually charge this thing up because it's nighttime. So we're gonna charge it up with an AC adapter first. Now the battery is charged and we're gonna do an inverter test. But they also sent me the inverter specs because they have seen other videos and they wanna make sure that I test it properly. So it has a 1000 watt surge capability. It's a 500 watt inverter. But if you pull 500 watts continuously, you will only get 50% capacity. And then if you pull 415 watts, you will get 88% efficiency, and the maximum efficiency that you can get is 88%. And they also sent me the watt hour at various discharge rates. This does not have to do with the inverter. So if I were to pull from this cigarette lighter receptacle directly from the battery, at a 0.3 discharge rate, we will get 450 watt hours. And at that rate of 0.3 C, that's like around 135 watts. If I were to instead pull it at a 1 C discharge rate, that means pulling like the max from these DC receptacles, I would get 432 watt hours. So I'm going to do a capacity test, but because we have those numbers, we can do an accurate assessment of, how much power we can expect to get out of this thing. So we're going to use a 500 watt work light, but I've tested it with a watt meter before and it does 480 watts. So we're going to do a maximum load test and we should get 50% capacity. And this is a pretty demanding test, all right? This thing pulls that full load for the whole duration of the test. But it's a constant load, and yeah, this is a great way to test out these inverters, so I like it a lot. So on the output, it actually says 451 watts. Now let's see what the meter says. Let's put it on watts, 448, so 449. So the accuracy is pretty good, and it seems like this output reading is at the receptacle, which is really good. I like when they do that. I hate when they put it on the battery where people don't know how much they're actually pulling from the receptacle. So I should get 225 watt hours or 0.22 kilowatt hours. So I'm just gonna zoom this in and we are gonna run this until it turns off. And this will be a pretty fast test. It should cut off in like 30 minutes or 20 minutes or something. Uh-oh. So in this max load test, we pulled 350 watts at the receptacle, but it's an 88% efficiency inverter. So if you divide it by 0.88, you get 397, which is only 53 watt hours shy of full capacity. So I'm wondering if they just told me that figure that I would only get 50% capacity because they wanted me to be more surprised and shocked when it did better. I don't really know, but that's really, really good. It's almost too good. So it makes me skeptical if they were under exaggerating their test results, because that's incredible. So what we're gonna do is turn this light back on and see if it can turn on again. And then we're gonna put a small load and try to get the full capacity of the battery. But considering the C rate was well above what it was rated for at this capacity already, it's already like surpassed the expectations in multiple ways. Battery, inverter wise, cutoff wise, everything. So yeah, let's turn this light back on. Oh guys, it says it's dead. So it ran until it was completely finished. Let's try to turn it on anyways. Yeah, I can't get it to turn on, you guys. So the inverter light is flashing when the battery is too low, just so that you know. So that's our final result, almost 400 watt hours, 397.7 watt hours. You know, it's so important to derate your units. If it's a 1,000 watt inverter, call it an 800 watt inverter, because when people review it, they do a test like this, and it's like, oh my gosh, that's so impressive. And if every manufacturer did that, their products would look amazing, especially with electrical stuff. Anyways, yeah, let's wait till the morning and we'll get the next test going. So now we're gonna charge it up with 2 solar panels, and they're 100 watt monocrystalline panels. And they're folded panels similar to the Renogy, but you have Anderson power pole connectors, and you can put these panels in parallel. So each solar panel has a long cable and a short cable to connect to the panel next to it. So for one of them, we're gonna plug it into here. And this is the cable from the second solar panel, so we're gonna connect it to this first solar panel. And now we have double the solar power input. And we're pushing 140 watts. So we are maxing out the solar input, and we're gonna start the stopwatch. And so it should take 3.5 hours to charge this up from 0. And while it's charging, we're gonna put it under the solar panel so it's shaded. So we've been charging for 4 hours, and it is not fully charged because we have this huge tree and it's winter time. And I can't seem to get enough sunshine on these panels, but it's mostly charged. It's like at 75%. And we're gonna do the remaining charge with the Tesla. So I just plugged it in, and we are charging at, oh, I didn't plug it in yet. So right now we're getting 62 to 65 watts continuous. which isn't that much. It should be pushing more. I know with the Tesla, because I've been experimenting with it, it might need to take a second for the converter to kick on, and then the voltage will jack up to 14.5. So yeah, let's give it a second and see what happens. So the charging speed has not increased, so I'm going to check what the voltage is at the receptacle. We have 14.2 volts. So it should be charging faster. Oh, I think I know why. It's because of this chemistry and the charge circuitry. You need that voltage to be higher with the MPPT. But we don't have higher, so I think this is the max we can get. But yeah, the max I can get right now is 58 to 65 watts, which isn't that great. So now we're gonna plug it into a Goal Zero lithium. This is an unregulated 12-volt receptacle, so it probably won't charge nearly as fast as the Tesla, or so I think. You guys won't believe this. The voltage is so low because it's unregulated on the Goal Zero side that it cannot charge with it. We're getting nothing, and there is voltage at this receptacle. See, we have 11.76 volts, so it will not charge from a Goal Zero. Now we have a 12-volt regulated output on the Jackery. Let's see how fast it charges. So it turned on, but this is only 13.2 volts, so let's see how fast it can charge. And we have 0 watts, guys. I've been waiting for about 5 minutes and nothing has happened. You cannot charge this with the Jackery. Actually, we can charge it with the Jackery because we have the AC adapter. So we're gonna have some losses doing it this way, but it will work. And what this makes me realize is the voltage requirements for charging this with this charge circuit. If you want to charge this quickly, you need to have a high enough voltage. If you connect it to a car or cigarette lighter, like I just showed you with the Tesla, we only pulled 65 watts. So you need to have like 20 volts or something to push the full 140 watts or around that much. Or a working voltage of most 12-volt solar panels is 17 volts. And this power supply delivers 19.5 volts. So that's the sweet spot. If you want to charge this quickly, it needs to be at least 17 or 20 volts. Because 14.5 and 13.2 is not cutting it. So now that it's charged up, we're going to do the official capacity test. We are going to find out the capacity of this battery with a watt-hour meter. And we're going to do it through the unregulated 12-volt output, so we don't have to worry about inverter losses or anything else. But you have to make sure that this does not come out for the duration of this test because this needs power. So we're going to tape this in here. I've had these come out before and it ruins the whole test. And these tests take like 3 hours, so I'm not going to do it a second time. And these are 10 gauge copper wires. This can handle the load. And for the amp rating of this output, we're going to do a 10 amp load at 12 volts. So like 100 to 120 watts. And I need to find a load still, so hold on. So I'm lazy and I've got this 12-volt inverter, so yeah, let's get this started. What the hell? I can't get it to turn on. Guys, it's not turning on. It just flashes the output. I don't understand right now. I'm not getting voltage. Every time I connect a load, it starts flashing and I can't power my load. I do not understand what's going on right now. All right, let's try a different load. I guess it doesn't like the inverter. That's weird. All the other ones can handle it. What I don't understand is I'm not even turning the inverter on. So let's try a different load to see if it can work somehow else. So we have the lights and they just turned on, but because this is not regulated, these lights are going to draw only like 15 watts. So I need a larger load. That's why I have this inverter. So let's try to hook up the inverter. But you know what we should do is use the inverter, do the last test that we did, but just have a smaller load, not a 500 watt load, but a 100 watt load. Because this is just not working that well. I just cannot stand when they're not regulated. If I was a manufacturer, that would be one of the first things that I would make sure is on every single unit for all of them. But you guys know my thoughts on that already, so yeah, let's try something else. All right, so the inverter's on. Let's get out our watt meter. Honestly, if these are not regulated, I would just say that they're unusable. You can find your own way to regulate it, but it's just not useful if you do not have 12 volts at the 12-volt receptacle. We have 137 watts. That's actually perfect For the C rate, that's like 0.35, so we should get nearly full capacity with this test. And on the front, you can see we have 130 watts. And on this side, we have 137 watts. So let's turn it over to kilowatt hours, and we need to hit 0.45. But this is at the receptacle, so I still need to calculate the inverter losses. So let's run it and see what happens. So now that we're done testing it, should you actually buy the Safari LT? And typically when I do these reviews, I imagine there will be a couple pros and cons and that's it. But after you guys saw with the test results, there are quite a few pros and cons. So first off, it does charge faster than any other solar generator on the market at this size battery. And if you have 200 watts of solar panels in direct sunshine, you will get 140 watts. But if you try to charge it with the car, the max you'll get is 65 watts. And so if you actually want to charge this at a fast rate with a car charger, you need to hook up your own inverter in your car and then connect the speed charger directly to this. There's no other way to get that wattage at the voltage that your alternator will produce. We tested at 14.2 and we could only pull 65 watts. Next, something that I dislike is that the power on button, that works. In the backlight, this button is good. When I pressed the output one, it worked right there. But as you guys saw earlier, when I have things connected, it would not turn on, and I couldn't figure that out. And then also with the inverter button, when you press it, it should be turning on right now. Am I doing something wrong here? Now it just turned on. So it always takes me a few tries to turn it on and off. See, it just took a couple tries to turn it off. So I did not like that. And it's funny that it's having this problem with the buttons because I've noticed with the reset button on their battery system, the lithium iron phosphate 1200 watt hour battery, it is very hard to reset it. You have to get the timing just right. So I think that the engineers designing this need to work on the buttons, because if you use like a Jackery or another solar generator like a Goal Zero, you press the button, it turns on, it's on. When you press the button again, it turns off. I've never ever had an issue, but every Lion Energy product that I've had, I have to like keep pressing it. So it's just kind of weird. I don't know how they have the timing or the threshold or how long you have to press it. But whether I hold it down for a long time or tap it, sometimes it works, sometimes it doesn't, and it drives me nuts. The next thing that I dislike is that the cigarette lighter receptacle is pretty much unusable because it's unregulated. And I knew that from the beginning, and we talked about it earlier on in the review, but I wish they could make these regulated. You know what's funny though is Lion Energy makes lithium iron phosphate batteries, and on their eBay store they even sell the raw cells, aluminum cased ones. Why don't they put those inside of here? You wouldn't have to regulate the output. You would have a higher nominal voltage throughout the whole discharge curve. Like, there are so many benefits, and it would last like 5 to 10 times as long as NMC, nickel cobalt magnesium oxide, that they're using inside of here. So if they could use lithium iron phosphate, they would solve this problem, and I would personally pay $100 more for that because it would last like 5 times as long minimum. So I wish that they could just change the chemistry and they would solve like half the problems that these small solar generators have. Next, I didn't even test these USBs because it's a pretty boring test and I've never seen one fail, but I imagine that they work just fine. Next, the DC power plugs. These are great if you actually have them and you like to use them, but most people don't use these things. So I kind of wish that they had like Anderson power pole for like a 30 amp connection for any solar generator. That would just be nice. Also, the screen works well. I like it. And it has worked every single time. And whenever I try to turn it off, it does turn off. So this button is good. This one drives me nuts, and so does the inverter button. But the case looks really good. I like the handle, and I like how it's black. It looks like a Batman thing. You know, like it looks freaking cool, right? It's like a high-tech little gadget. Next thing I want to mention is that if you use solar to charge this, you need 200 watts of panels. Also, they included an extension cord, and they even sent this out to me, but I didn't mention it earlier in the video. So what you can do is put this in the shade or an RV or a house, and then you run the extension cable out to your 2 solar panels. But what I dislike about this, and it has good rated wire. This is low voltage ground wire that's UV resistant, and you usually use it for landscaping. It's the same exact copper wire that they use in the Energy Apex, and it is good wire. I actually use it for one of my arrays outside, and I've tested it for over a year in San Diego and Las Vegas, and the sun doesn't bother it. But check this out. How are you supposed to waterproof this connection? When you have the solar panels connected to this looks good. You have Anderson power pole and you have, a cover right here, but this is not waterproof. So if you want to waterproof this, you're going to have to cut this sheathing and then put marine grade heat shrink over the whole thing. Luckily, this is not an EC8 plug, just like on the Energy Apex. This is a small Anderson power pole. So you could easily put heat shrink over this whole connection. Actually, let's pull this off real quick. Uh-oh, guys, we just found a bad connection. Check this out. So this is a manufacturing defect. This is not good. Look at how the wires are pushed back. This is a horrible job, and it's not even crimped properly. It just pulled out. Can you guys believe that? So Lion Energy needs to go back to their manufacturing line and fix this. This is a horrible red flag. This is like a failure right here. So this side looks good, but look, we have a strand of wire sticking out. Can you see that? That's not good either. Wow, that is a surprise, guys. I do not like that at all. This is horrible. You guys need to fire whoever did this. This will destroy your company. You guys, look at this one last time. And look at how the wires are bunched up at the bottom. That is just so bad. Horrible craftsmanship. Dang, that is pretty darn disappointing. So let's think about it. We have a fast charge rate and the capacity test came in great. But besides that, I think there's too many problems. And I really like this company and I really like the people that assemble it. But man, this is just hard to like. Manufacturing defect. The 12-volt unregulated output is a pain to work with this button. Inverter is a pain to turn on. So yeah, I think that they should go back to the drawing board, change out the chemistry, change the timing threshold for these buttons so that we do not have any problems with turning it on and off, and change the manufacturing because that is unacceptable. That wire should not pull out. I didn't even pull on it. Okay, it was already like that and it was not crimped properly. There should be a cold weld. That should be impossible to happen. So yeah, that's what I think about this unit. This is the full review. I hope you guys found this useful. I wanted to cover every aspect of the system because people were asking me like crazy about it. So there you go. I hope you guys found this video useful and I'll talk to you later. Bye.